Welcome in, everybody. Everybody having a good conference so far? Yeah. It's Thursday, and it's morning. So, yeah, this should be interesting, right? No, at least it's not 8 o'clock in the morning, because I might have showed up late, too. But welcome in. I'm glad you're all here. I just wanted to, welcome everybody, all that good stuff. But my name is Brian Boyd. I'm a senior research analyst with Rubrik. And I've done quite a bit of stuff in my career. I started with a Commodore 64. So does anyone know or have used the Commodore 64? All right, good. There's my 8-bit fellas in the house. So yeah, there's a lot of curiosity. It led me to some incredible experiences being with computers and things. And one of them was I served our country as a Army counterintelligence special agent. Safeguarding national security in the digital world, pretty fun. Then I joined the Michigan State Police, where I used computer forensics to crack cybercrime cases. So that wasn't enough. I wanted to build and protect things, so I spent over a decade ensuring data availability, disaster recovery for banks and hospitals. And then, because of my experience with the military and the police, I became a senior technical instructor at AWS teaching national security for about 4 years. Now I'm at Rubrik, and it's pretty fun. We're tackling the biggest challenges in cyber resilience head on. So essentially from 8-bit to cutting edge, it's been quite a ride, and I'm just getting started. So why are we here? We've got some graphs on the screen, right? So despite high security spend, attacks continue unabated within an environment. So on the left, we've got worldwide security spend is up, and I'm sure all of you have seen our expo center, right? Everything in there is about security. Even Matt Garman's keynote, one of the first slides he showed was about security. So this is a pretty important topic, especially when we're talking about cloud environments. And while worldwide spending for security is up, ransomware is still on a tear. So it's kind of a frustrating paradox because we're investing more than ever, but the bad guys are still getting through. So why should we even protect the cloud against ransomware at all, right? So I've got kind of what I call my 4 pillars of ransomware here. So cloud attacks are surging. Ransomware loves the cloud. Price of failure is sky high, and downtime costs are devastating. Now, don't take my word for it. I've got some proof points. Everybody likes data, right? So Unit 42 from Palo Alto Networks produced a report in 2024. They state that 71% of organizations experienced a cloud security breach in the last year. So that's a pretty staggering number, right? Cloud environments are increasingly targeted, and for a good reason. They're expansive, they're complex, and often riddled with less secure configurations. So those are pretty easy pickings for attackers. Now, I wanted to find some data as well out there, and I found different things on the internets, as you like to call them, and I discovered that there was an incident in 2024 with just misconfigured S3 buckets, right? So publicly accessible EC2 incidents were exploited to exfiltrate sensitive data. And in one case, attackers leveraged overly permissive bucket policies to escalate privileges and exfiltrate customer data. But there's more, right? So ransomware loves the cloud. Woo! 30% of ransomware attacks in 2024 now target cloud-hosted data. So what attackers do is they exploit those weak security controls, right? And this is not saying AWS has weak security controls by any means. This is, how they say security in the cloud, right? So things like misconfigurations, et cetera, can lead to these exploitations. So there was a scattered spider group. So this is an actual ransomware organization, pretty scary name. But they exploited Systems Manager inventory. So who uses Systems Manager? Anybody? Anybody? Yeah, there's a couple. Cool. So they actually exploited that. They identified vulnerable EC2 instances. They bypassed the traditional detection systems. They deployed ransomware, encrypting both primary and backup data. So that was a bad day for somebody. Average cost of ransomware demand is $7.6 million. That's like almost like Dr. Evil level, right? $7 million, right? So the financial impact of failing to secure cloud environments can cripple those businesses. And there was an iCare leaders breach. Attackers leveraged weak encryption protocols in an AWS hosted database. This allowed for unauthorized access to patient data, leading to compliance penalties and ransom demands. So they're targeting healthcare, they're targeting banking, anywhere they can get in, right? Downtime costs are also devastating, right? So extended downtimes can jeopardize operations, leading to substantial revenue loss. All right. So this is an interesting one. So this Postman Secrets breach. So can you imagine, for a second, if you are a developer and you have your public GitHub repository and you're working for a company and you save your API keys on a public GitHub repository. So that's kind of what happened here, right? So they used these keys, they got control of production AWS environments, causing service outages lasting up to 5 days. Now, when we see attacks of ransomware, 5 days is a long time, but we've seen, in the news everywhere, couple weeks, couple months, people trying to get back to things. And it is definitely an issue. So if we bring back my 4 pillars here, right? So we've got a lot of statistics out there that back up the information that I'm telling you here. But essentially, ransomware isn't waiting for you to act, right? So secure your cloud data. Insecure cloud data is a primary target for cyber attacks. So essentially, hackers aren't necessarily breaking in anymore. They're logging in. So let's take a look at how this happens, right? So we've got a threat actor. I'll name him Evil Steve in this scenario. Hopefully nobody named Steve is in the audience. I can change it if so. All right, so Steve goes in. He gains access to an environment, right? Then he starts poking around and he finds this shadow data. So what is shadow data, right? Shadow data is essentially, in context of a data breach in the cloud, it refers to unmanaged or unaccounted for data. So this could be a developer trying to develop something on the side. This could be leaving stuff out there, not cleaning it up. A lot of different things can happen there. But why is this important, right? So it's because this shadow data can then essentially start elevating permissions within an environment, right? So these folks get in, they find somebody else's passwords in the shadow data, they start elevating their permissions, they start expanding their footprint, and all of a sudden, we're into production, all right? Production databases, buckets, customer data, right? And then they start exfiltration, and we'll talk about that in just a moment. And then they can destroy and encrypt data. So for an attack, he'll go in, he'll encrypt data, and then here comes the ransomware, right? So how do attackers gain access? All right, so Evil Steve can do this in a variety of different ways. There's a zero-day attack, and unfortunately, zero-day attacks happen, right? So Not very good to prevent, but they do happen. Threat actor could get into a publicly accessible S3 bucket. And I want to be clear, S3, for the past several years, the service has the default to turn public access off. For whatever reason, people can still manually go in there, turn it on, and sometimes it's just misunderstanding of the service, right? So instead of making a publicly accessible bucket, maybe you should be using CloudFront in front of that bucket to protect your internal resources. So there's a lot of different tools that AWS offers to secure down your buckets as well. Unpatched CVE files. So do any of you have any unpatched EC2 instances in your environment? Now, I'm talking to security people probably, so that wouldn't happen, right? All right. And then exposed credentials, and we talked about the exposed credentials within GitHub, but also somebody clicks on a link in an email that looks fancy. A variety of different ways can expose those credentials. So let's take a look in a moment on the reconnaissance or lateral movement in our environments. So one of the ways that they do is they go ahead, they authenticate and impersonate a legitimate user. All right. From there, maybe they're looking around S3 buckets. Maybe they're looking around EC2 instances, etc. Right? Then they're evaluating access to objects within discovered buckets. And then they inspect those objects to discover sensitive data. They'll use that and then say, hey, I found some really, really cool stuff. I found credit card information. I found PII data. I found healthcare information. I found Brian Boyd's home address. All right, so they start a data exfiltration process, and then they begin that data encryption process. Whoops. Go back just a sec. They go through that data encryption process, and then they start their data destruction. All right. So what is a cyber incident versus a cyber breach? All right, so an incident can happen a variety of different ways. We've talked about that throughout this talk. We can do some data destruction, but also that data exfiltration, that pulling of sensitive data, et cetera, can happen. So not only are you dealing with a cyber recovery event, but you're also dealing with some data posture stuff as well. So we believe at Rubrik that a comprehensive data-centric cyber resilience strategy is a must-have in order to prevent data breaches and avoid double extortion. So this is kind of a cool way to look at all that. So if you look at the left, I've got peacetime, and on the right, I've got wartime. So this is an actual exploit that happened that Unit 42 analyzed. And what they analyzed is there was an exploit of an env file with AWS credentials that were publicly exposed. So this is how the attacker got in the beginning. Now, attackers don't always ask for ransomware right away. They can go in and they can say, hey, I'm going to start looking around this environment. I'm going to see what I can find. And then I'm going to start poking around some more. All right, so we're poking around some more in our environment. We're creating new IAM roles. We're attaching IAM policies to existing roles. We're exfiltrating the data. And then we have this impact, all right? So the impact is this exclamation point. So now this is when you get that ransomware note. You get folks saying, hey, I can't get onto the website. What's wrong? And everybody's running around trying to figure out what's happening. You will be doing engaging of incident response teams. This could take immediately. This would also happen within a couple hours. There was one that I know about as well that it took about 12 hours to engage the incident response team because the on-call network engineer just didn't know the gravity of the situation they were in. So once that incident response team gets in, then you're trying to find like clean backup copies, right? So you're saying, okay, well, where did they hit us? Let's go ahead and test and plan recovery with IT ops. Let's restore business operations, right? And this could be hours. We've seen days. We've seen a month, and this process can take quite a long time to happen. Now with Rubrik, we saw this as a problem and we said, hey, let's take this attack timeline. It's the same attack timeline, right? And let's introduce some sort of attack. So a pre-attack, maybe there's some active intrusion coming on. We have ransomware discovery, sensitive data discovery, data security posture management that can take a look at all this stuff going on before an attack. And if you do get hit by a ransomware note, we can quickly find a point-in-time copy, revert back to before the attack, and then do the analysis and find those files that the attacker and exploit that they may have done. So with data security posture and cyber recovery, that offers us that complete cyber resilience package. So I want to go through a couple best practices for cyber resistance. Okay, so I like pillars. I think it was back from my my Amazon days. Pillars are cool. So 4 things. You want to eliminate unnecessary data, limit access controls, continuously assess data posture, and then monitor activity within your environment. All right, so let's talk through each one of these, right? So eliminating unnecessary data, what does that look like? Who used tags in AWS? Tagging, yes, you're my friends, awesome. So yeah, inventory and track data containing assets globally. So tagging, use the utilities AWS offers you to do that inventory, systems manager, all those things are very, very cool. Rubrik also helps you with this as well. Scan assets for sensitive data. So within Rubrik, we've got sensitive data discovery, DSPM, AWS, you've got Macy, you can write a Lambda function, start going through your data and looking for sensitive data as well. Understand it, so classify it, categorize it, find out what context it's within, and then is this a legitimate use, or does somebody have their MP3 collection still on their S3 bucket? Don't ask me why I said that. Okay, so eliminate unnecessary and redundant data. So you want to delete, you want to use archival processes, and you want to rot data. What is rot data? Anybody know? Okay, redundant, obsolete, trivial. So, all right, second one, limiting data access. I mean, this is kind of a no-brainer, but let's take a look at what this looks like. So inventory all users, groups, roles and groups. So you can use AWS Access Analyzer, I believe the service is called, but pay attention to external and anonymous access as well. Audit access to all the data, so especially critical or sensitive data. So if you're a hospital, if you're anybody with 911 systems for a county, so audit access to all that data. Limit access, so you want to start limiting it by reducing unused permissions, eliminating anonymous access, restrict third-party access, and use IAM Access Advisor as well. Adopt best practices. How many times have you heard, use MFA? Please use MFA if you're not. Switch users to roles. Don't hard code credentials within your files. Roles are great, right? Revoke inactive users and roles as well. You can use IAM credential report to help you out with that too. So a lot of different options you have within AWS as well. Next up is continuously assess data posture. And you saw this on the floor this week, a lot of data posture management people out there. There's a reason for this. We do that too, right? So it allows us to minimize access to data. It also allows us to take a look at encrypting data at rest and in flight. Make sure you're using encryption. Logging, all right? So server access logs, CloudTrail, Amazon CloudWatch, etc. Within Rubrik, we also have extensive log activity and reports that you can run as well. Enable and test cyber recovery. So backup, time series, immutable, air-gapped, observability. Those are really, really good things to have. So make sure that whatever solution you're choosing, use immutable, verify that, make sure things are air-gapped, etc. And then lastly, enforce data resilience. So using things that's built into, say, for example, AWS S3 or Amazon S3, versioning, object lock, MFA delete, AWS config, all these things can help you in the event of an attack. Excuse me. All right, monitoring activity. So focus on critical data, interrogate anonymous and external data, and then detect and respond to that anomalous activity. So suspicious source location, like all of a sudden you're getting stuff from Australia and you don't have any Australian customers, or Russia, or a variety of different countries out there that you don't typically deal with businesses. You may want to monitor that to see what's happening. Suspicious user agents, like somebody's using the SDK that you're not really aware of out there. The suspicious sequence or frequency of events as well. So I'd like to talk to you about how Rubrik does S3 protection. Now, we do a variety of different workloads, and we don't have a lot of time to cover them all here, but I thought that S3 was very appropriate given the subject talk and all the things we're talking about today. So on the left, we've got Rubrik Security Cloud. So we're taking a look at a high level. And this is the SaaS management plane where you manage all your AWS accounts and S3 buckets. And next, we've got a dedicated AWS account per customer managed by Rubrik. So within this account, we store customer-specific IAM users that are leveraged to assume the cross-account role and gain access to the customers in the AWS environment. Finally, we have a customer-managed AWS environment. So this can be one account, this can be several accounts, and these accounts host both the source data and the backup targets for S3 backups. So backup data, as shown, can be stored in either a different region or an entirely different AWS account. So all Rubrik Security Cloud does is we take the metadata and we take a look at the metadata, and that's how we can do the indexing and things within the SaaS platform, but all the data is still owned by the customer. So we chose S3 because of its durability, right? So I'd like to invite now Bijeta. She is a senior product manager at AWS for S3 to talk more about how Amazon S3 achieves its high level of durability and reliability. Welcome, Bijit.
Hello and welcome to this session. My name is Bijeta Chakraborty. I'm a senior manager with Amazon S3. We love working with Rubrik. Now, while they're living and breathing data protection solutions, we in S3 wake up every day living and breathing the fundamentals. The fundamentals, the way we see it, it's availability, security, durability, performance, and scale. Durability is special. It's the most important one. It's the most important one for us. It's only second to job zero, which is security. In fact, we talk about fostering a culture of durability within Amazon S3. Now, for the next 10 minutes, I'll talk about how we achieve the 11 nines of durability and how we do this across 400 trillion objects and across millions of hard drives. We look to exceed this durability rate, and we consistently raise the bar every day, every week. So there are really three key things that we do that help us achieve this 11 nines of durability. First, end-to-end integrity checking of all requests in S3. So when Rubrik hands us an object in S3, we check it with the checksum, we checksum it along the way, and then we checksum it when we persist the data to disk. That way we can ensure that the data that Rubrik handed us is indeed the data that we store in S3. Second, we always store the data across redundant devices to be able to tolerate concurrent device failures. And we do this so that the object integrity is maintained. And then third, we do periodic durability auditing of the data at rest to make sure that the data that we wrote to S3 stays right over time. Let's talk a little bit more about how we do this end-to-end integrity checking of requests. So when a customer gives us an object at the S3 front door, we checksum that data at the front door. Now this data is flowing through multiple different systems within S3. These systems may be transiting the data, they may be encrypting it, they're doing various different things. Now, every time the data exchanges between two microservices within S3, we checksum that data. This is called checksum bracketing. Checksum bracketing is this end-to-end technique which ensures that no data exchange happens without a checksum accompanying that data. Next, we store this data across multiple devices within a single availability zone. And in the process of persisting this data, we actually read that data back and checksum it to make sure that the data that we intended to store is the data that we stored on disk. Next, we loop this checksum back to the checksum that we calculated at the S3 front door. And only if those two checksums match, we send you back a 200 success message. Now, our story for end-to-end integrity checking of requests would have ended there. However, just this past Sunday, we introduced a new feature. We launched the ability to perform high-speed CRC checksums across all of the latest AWS SDKs by default, which means that S3 will not be accepting an object without confirming the object integrity over the wire. For example, the public internet. Sorry. And we're doing these end-to-end integrity checking for every single put or write request to S3, which means we're computing billions of checksums every single second. The second thing that we do is that we're always storing the data across multiple devices, which means we're able to tolerate concurrent device failures, because we all know that devices can fail. We're architected for device failures. As you can see here in this image, we have objects A, B, C, D, and E kind of spread out across redundant drives. And we do this such that if a device goes down, we're able to repair the data due to the redundancy that we're maintaining. Now that was an oversimplified image of how we're spreading the data across redundant devices. This is sort of what it looks like at scale. There's really two key things to remember here. We always keep adequate spare capacity so we can repair to the redundancy level that we want. Next, we are aggressively monitoring for failures. In fact, we have an independent auditing fleet in S3 that's solely responsible for detecting device failure so that we can quickly respond and repair redundancy. The third thing that we do is the periodic durability auditing for data at rest. We have an independent auditing fleet that's scanning all of the data at rest. It's designed to detect rare edge cases like bit flips. A bit flip can happen due to a bug in the firmware that's way down in the infrastructure. However, it is a durability risk, and we do not tolerate that. So those three big systems that we talked about, the end-to-end integrity checking, the data stored across redundant devices, as well as the periodic durability auditing of the data, they're all working together within a single availability zone. And that's giving us quantitative inputs into our durability rate. So we know exactly how often our devices are failing. We know how long it's taking for us to repair to the level of redundancy that we want. We know how many checksums we're calculating. We know how often data is being scanned in S3. So all of those are facts. Now, those three systems work in a single availability zone, but S3 is multi-AZ by default. So imagine spreading all of those three systems across multiple AZs. Now remember we talked about sending you back that 200 success message only when the checksum at the S3 front door matches the checksum of the data that we persisted on disk. All of that holds true when we persist the data across multiple AZs. Only once we confirm that the data was truly persisted across the multiple AZs, we send you back a 200. Now the key thing to remember here is that when you see a 200 success message from a write request on S3, that's a contract that all the things we discussed here were done. The data was integrity checked, it was stored across redundant drives, as well as it was persisted across multiple AZs. With multiple AZs, you also get the benefit of availability in addition to durability. So let's say there's a power outage that takes one of the availability zone down. S3 can route around that failure and serve you your data without you even knowing about the ongoing issue. All right, so just to recap, we talked about the 11 nines of durability and how we get it. The first approach is the end-to-end integrity checking of all requests in S3. We store the data across redundant devices. We do periodic durability auditing of the data. And then third, all of this data, and then fourth, all of this data, is persisted across multiple AZs. Now I'll invite Derek on stage to talk about some real-world examples of how Rubrik is helping customers protect data on the cloud.
Awesome. Thank you so much. That's a really long walk-up. It's like WWE style. I got to come running in. Is anyone here Canadian by chance? All right, you guys are going to need to get your Google Translate out because that's me. There's going to be some things that don't come across, so that's going to be all right. My name's Derek Keane. I've been in data security for about 12 years, worked at a bunch of different vendors. I came over to Rubrik about 1.5 years ago, joining the data protection team, which is really responsible for the cyber recovery piece. Because of a really unfortunate story that happened up in Canada. It was a Christmas time about 2-3 years ago, and what happened was our provincially funded, which is like a state, bus service essentially got hit by ransomware. And so you can imagine Christmas Eve, no one's able to get on a bus, no one's able to get on a SkyTrain, which is like our subway system, to go out and do what they needed to do. And some of the vendors that I had worked with and around were doing all the preventative controls for this organization. Yet they still got impacted, they were still hard down, and in my mind, I just had like, little grandma can't get to her family dinner because the organization is just totally down. And what I saw was that there was an outcome, especially being on the sales engineering side, that I want to sell back to executives, which is, can we recover our business? Can we come back online quickly? So I kind of took a brief pause, about a year out of the kind of cyber posture piece into the data recovery piece, and then we went in and we started to invest further on the cyber posture piece. So now I found myself coming back full circle. And what I've been able to do as we've kind of grown out the cyber posture piece at Rubrik is bring some of this multilingual department work that I've done in the last 12 years. Because I think when we start talking about cyber posture in our data, there's far more things that are, or far more departments that are involved than just security and just the users. You've got risk, compliance, and security that really make up who's going to consume this data, right? At the end of the day, data is great, but data decisions have to be made. And at the end of the day, business outcomes have to come out of it. So it's nice that you can have 10 different tools doing 10 different things, giving all this stuff, but who cares? Like, who's actually using it? Who's actually driving decisions out of it? And what happens when all those things fail? So what I've been able to do is I've been able to jump in with the data and help organizations that are heavily invested in the recovery piece start to see potentially what the situation would be if they were to get hit like that bus company. And that's been a ton of fun for me. The challenge I've found, I got young kids, I watched way too much Harry Potter, but this is kind of the analogy I give, which is a Cerberus, which is a three-headed dog. And at the end of the day, that's the way I look at what data has to be kind of dealt with. Is any data that you're pulling out of these tools, out of these assets, when you're dealing with an investigation, when you've got a user that did something really stupid, you have to come back and talk to 3 different departments. You have to speak their languages, because their languages are different. If it's government, if it's GDPR, or if it's a security analyst that's actually going through and trying to figure out what the hell happened, or if it's someone in operations that's going, oh man, now I'm going to be the one that has to make that change. What is that change? What does that best practice look like? So when I'm talking to our teams and our champions, we try and get everyone together in the room and try to get them to basically eat the data, is what it comes down to. That dog lives and grows, and business outcomes come based off of the data we're able to pull out of different tool sets. So when I talk about outcomes, this is really where I break it down into. And I'm sure you guys have seen all the events. We've got about 20 minutes to lunch. I'm sure you guys have gone through and seen a whole bunch of stuff out in the floor, AI, Gen AI, all that kind of stuff. But at the end of the day, someone's got to do the work, right? So how do we guide them? How do we make them better in doing that work? Right now, obviously, things like DLP are front and center. People are trying to put better controls around both on-prem and cloud assets. So they need to know a little bit more about what their data looks like. You got things like AI, different LLM models coming up. It's got to consume the data. So what kind of data is it consuming? If you can go into your chatbot and you can say, hey, tell me who got a raise last week, that is a fundamental failure, right? So we need to understand, what does the data look like when it's being consumed? Is that a security thing? Is that a compliance thing? Is that an organizational thing? I mean, it's kind of all of those things. Security still needs to know about behavior. What are users actually doing with that data across all these different platforms? And that's extremely, extremely hard when you have potentially multiple different tool sets and multiple different departments and people looking at that. You can't consolidate that information to make an actual outcome that people can follow and do and get to the end of these projects. And then you start to bring the other people into the room around compliance, right? Compliance really, really cares about this data, right? It's their baby. A lot of times they don't even have the technical acumen when it comes to what's happening from a security point of view when that data moves or when that data changes, right? They might be asking for a report, they might be asking for an extract, they might be asking for a copy of the data, but where are they putting it? Is that going to be a security concern? Is that going to be an operational concern? When new things change, like GDPR just had some major changes, who's going in and updating the tool sets? Who's going in and actually making sure that they're going to be able to get the data they need and it's going to be done properly? Right. And then operations, operations. So I started myself in help desk, worked my way up, became a consultant, and then got into sales engineering. And I always empathize with the operations people because we can sit around and we can sell tools, we can do this and that, but at the end of the day, someone's got to press the buttons, right? Someone's got to turn this thing on, monitor it, make it work, and at the end of the day, be accountable to a lot of the cost that gets spun up with this, right? If you have people that are taking prod buckets and putting them out into dev and doing great things with them. That's awesome. But when the business comes back to them and says, do we need this data? Is it sensitive? Can we get rid of it? Why is our bill so high this month? Or why was there significant changes in our bill? It's just as scary seeing it go down a whole lot, just as much as it is seeing it going up. It's kind of like the good and the bad. Someone goes in and hacks your account and nukes out all your data. It's like, it's going to have a cheap month that month, but it could be an expensive one next one. And then really understand and eliminate shadow IT. So one of the big challenges I see is compliance teams go, we need to find all of our sensitive data. So they start this whole procurement process and they go and they grab a tool set and they bring in vendors and then they walk over to operations and say, hey, go deploy that, go make that thing work. And security goes, dude, I got 4 tools that already do that. Like, what are we doing here? What are we trying to achieve? And what I'm seeing fundamentally break down is that no one really speaks these 3 languages and no one can bring them together to make it work. So we end up as a whole lot of shadow IT. You got a bunch of repositories, you got dark data, you got dark tool sets that are out there not bringing any value. Okay. So I got some 3 examples that I'm going to talk through. Just incidents I found. Obviously, we've got screenshots from our product and all that, but what I tried to do is not find like crazy 0-day stuff that's all out there. I just wanted to find some really common examples of where fundamentally the process is broken within an organization and how if you put just a little bit of visibility in it and you get a little bit of metadata about your data, we can start to drive towards some outcomes. So the first one is overexposure, super common. You can have, whether it's, something like a SharePoint or an S3 bucket, you can put overarching organizational layers on not letting that sharing happen. What I'm seeing a lot of is that's done really, really well in the production layer, not done very well in the test, dev, staging, Joe's secret bucket, whatever that is, right? Sorry, Joe, but those things come and they exist, and sometimes those controls aren't applicable there. So then people turn on and overexpose data, and then we get into a situation like we had here, where we've got a bunch of S3 buckets that are just wide open to the world, and that's just like a ticking time bomb. And that report that we referenced earlier, they said it's about 12 minutes for the initial enumeration of that bucket once it goes public. So if you don't have something active to understand the data, through that data and tell you, hey, this is a problem, you got about 12 minutes before this is going to potentially be leaked, right? If they're nice, they'll just delete it. If they're not nice, they'll, go find out what it is and double extort you on it. So in this case, what we needed to do is we needed to understand very, very quickly what was in this data. And in this case, it was, just basically a dump of a production database. The file itself was a SQL backup file, right? So that's a really, really hard one to put into an operation. Even if you knew the second that bucket turned public, in those 12 minutes, are you gonna be able to go into a SQL backup file and get this kind of metadata out of it? Are you gonna be able to discern and make a decision about that situation within 12 minutes? Probably not, right? So the whole conversation that we've been talking about recovery, I'm more focused on the posture side, and I wanna help organizations do this and see this so that they don't have to get into a recovery point of view. They don't have to get into, getting into the news, not letting grandma get on the bus. Now the next one I'm gonna talk about is about as basic as it comes, okay? This is about data locality. And this, I can't talk about the second part of it, but I can talk about the first part of it, which is what this data essentially was and what we saw. So within an organization, we had a whole bunch of data, lived in AWS. I'm gonna say the A word, Azure, but this data moved on over to Azure, and someone figured out, due to lack of configuration or just being generally malicious, that they were able to spin up an Azure file share in central India. They're just gonna dump that data there, okay? Now, normally you'd go, okay, that's a little bit anomalous, right? We've got an area we're not utilizing, it's spun up, we've got a functional control there. But what I find really interesting and what I really try and dive into is obviously the metadata, right? What's happening around that data. And what we're able to see within this is that we've got a 5 gigabyte IMG file, okay? Is that the world's largest cat pick, or is that a rip of someone's hard drive, right? I can't tell you what it was, but I can tell you it was worth investigation. And just very, very simple things like this. Where is your data living? what kind of behavior, get your spidey sense going, what's going on with that. It can lead to some really interesting outcomes. Because is this an operational problem? Is this a security problem? Is this potentially a compliance problem? Yes. Right? Do you functionally have the ability to sit down with all three of those people, explain the situation, and get to an outcome which is de-risking the business and solving a potential exposure? That's something I would challenge everyone to think a little bit more about and play a little bit more in those sandboxes. Okay. The next one I'm going to talk about, and actually the last one, is about data movement. And I really like this example because it brings all three groups into the same house. It's a perfect example of where I would say the concept of shadow IT is kind of applicable. It's more about just people doing things without really bringing in consideration to what other people have to do with the data. And in this, we saw was a prod database gets dumped down into dev. Happens all the time. That's great, no problem. But this was like the database, right? This had all of the information that this customer thought was most important. So did it go public? No, because we found this before someone could flip that over, right? We were able to show that visibility and make sure that they understood that, hey, like the keys to the castle, like literally just got dumped into somewhere where they shouldn't be. But what was more interesting to them is that they had all these workflows that kick off whenever they discover GDPR data, right? If anyone here has to deal with GDPR, CCPA, PCI, right? It's not super fun. And the last thing you want to know is that a whole bunch of that data has just been duplicated or moved or created in a different place. And if you don't know that, a lot of times ignorance doesn't really hold up in the case of law, right? So we need to know where this data is and where it's moving. In this case, we saw a ton of information, passport information, country information, first name, last name, like EU is just kind of frothing at this kind of stuff. This is, precisely what they're looking for when they see organizations mishandle GDPR data. Okay. So, some takeaways from this was we were able to see this before it became a big problem. That's a big win. And then secondly, we're able to bring these departments together and kind of work through it and say, hey, this happened at an operational level. Governance, what are you going to do? Compliance, what are you going to do? Security, how are you going to put better controls in play? Okay. All right, so getting to the last little one before we let you all go for lunch, there's a whole lot here. I'm not going to talk through all 8 of them. What I will do is I'll leave you guys with a little bit of homework. There's kind of like 3 major concepts outside of what we're doing differently with cyber resiliency, cyber recovery, cyber posture. 3 things I would want you to think about is data defensibility and metadata defensibility. Okay? When I've seen attacks, a lot of those systems that you're relying on to help you recover in an attack are gone. Like you're going to have to restore them from months-old backups just so you can restore your other stuff. Right? We need to ensure and make sure that not just the backups are secure, but what about all that security tooling you have? What about the information you're relying on within that security to be able to report back to the board, to report to an auditor and say, hey, yeah, we're in the early stages of this attack. We know data has been exfiltrated, and here's what we know that is. There's a really, really big difference between 1,000 people and 1,000 people records being part of an exposure versus millions, right? So can your systems do that? Are they going to be defensible in that situation, right? Do you have a data vault as well as a metadata vault? And then lastly, there's 8 things on here. There's probably 200 vendors out there that can do some of these things. And you've got organizations that have invested probably multiple times in each of these things, right? Let's get all 3 departments together, especially in like larger enterprises, and let's see what everyone's playing with and where we have overlap and where we can do some tool consolidation, where we can drop some costs. Okay. That's it. That's all I got. Thanks everyone for attending. We're going to be out in the hall if anyone has any questions, comments, concerns. And yeah, thanks very much.